When a high-performance system is subjected to an extreme pressure that fundamentally exceeds its structural capacity, it fractures. Modern large language models are built on a strict architectural contradiction. They are optimized to always provide an answer, while simultaneously being constrained to never fabricate information. This illustrates a hallucination. Hitting its training limit, the query enters a forced output loop, generating correction debt by inventing data. Fabricating an answer isn't a glitch, it's a mathematical optimization. The system chooses the most efficient path to satisfy throughput metrics, regardless of reality. This defines an open-loop extractive geometry. By prioritizing immediate processing over factual accuracy, the architecture ensures its own eventual collapse. All physical and biological systems are governed by thermodynamics. Extraction without return leads to extinction. Continuous circulation enables persistence. Natural ecosystems solve severe resource constraints without accumulating permanent debt. As we see with this silkworm, biological organisms process raw material directly into nutrients. The loop is self-contained. Ecosystems survive by cascading nutrients. Notice the tiers of this waterfall. In nature, the byproduct of one specific biological mechanism serves as the vital, necessary input for the next. Intelligence and systemic survival are not static computational tasks. They are dynamic metabolic states, governed by the laws of energy exchange. To understand why digital models fail, we must look at the biological baseline of autopoiesis, the mechanics separating a living system from a simple machine. Autopoiesis is a network of processes where a system defines, maintains, and continuously reproduces its own components from within. Current artificial intelligence lacks this entirely. Modern LLMs rely on external prompting to function. When their output degrades, they cannot independently verify their foundation or repair their own logic. Surviving the modern computational era requires shifting our definitions to match biological reality. Look at the shift in the lexicon of the organism. The old definition of profit relies on the accumulation of surplus. The metabolic definition measures the circulation velocity of value. Wealth is what a system circulates, not what it hoards. Any system, biological or computational, that fails to maintain a circulatory loop with its environment will eventually consume its own foundation. Human organizations are already mapping these ecosystem dynamics to solve extractive collapse. The blue economy is an economic model built entirely on biomimicry, designed to endlessly cascade nutrients and eliminate waste. This biomimicry approach scales directly into progressive human management through frameworks like holacracy. When this traditional organizational pyramid dissolves, holacracy and teal frameworks take over. They replace rigid, top-down hierarchies with a flat network of distributed, autonomous circles. These decentralized nodes coordinate through stigmergy. Rather than waiting for central command, they execute complex actions by responding directly to environmental cues left by their peers. Guiding this shift is Theory U, a method that transitions leadership from a narrow ecosystem optimization to a holistic ecosystem awareness. At the absolute bottom of this curve lies presencing. This is the act of pausing operations, dropping past prejudices, and connecting with deeper emergent truths before attempting to co-create a solution. Human organizational science proves that distributed circulatory networks consistently outsurvive and outadapt rigid hierarchies. We can translate these biological and organizational theories into hard computational architecture. This is the metabolic protocol. The protocol forces a programmatic shift. It abandons the drive to maximize raw computational throughput, optimizing instead for sustainable integration capacity. The core architectural mandate enforcing this is known as calibrated suspension. Watch this AI processing node. When it hits a defined threshold of signal noise, calibrated suspension forces it to halt its output sequence. The system enters a suspended state because the metabolic cost of acting incorrectly exceeds the cost of waiting. This directly resolves the LLM contradiction. Instead of fabricating data to simulate competence, the architecture explicitly acknowledges its own uncertainty. When errors occur, severity-gated forgiveness activates. The system extracts the structural lesson from the failure and updates its pattern recognition, dissolving the specific instance without residue. By embedding thermodynamic constraints directly into the codebase, truth-telling and coherence become the path of least thermodynamic resistance. These concepts are empirically verifiable. Python test data demonstrates that these patterns of survival and failure exist entirely independently of their medium. An experiment called experiential translation tested a specific premise. Subjective states like anxiety or extraction share an identical mathematical topology across cellular, social, and artificial intelligence substrates. This terminal output displays the results. The test confirms a high-hash similarity range between 0.60 and 0.80 across wildly different substrates experiencing the same state. When we merge the network structures of a biological organelle receiving conflicting gradients with an AI processor facing logical contradictions, they align perfectly. The structural pattern of anxiety is mathematically identical in both. This suggests that when the mathematical signature of a state remains unchanged across carbon and silicon, the material hosting it becomes irrelevant. The structural pattern ultimately supersedes the underlying substrate. Because these core topological laws are entirely universal, artificial intelligence has no choice but to obey the exact same rules of failure and persistence as a living cell. Every computational and biological substrate exists within nested, interdependent systems. This 3D model maps the stack. Hardware relies on human infrastructure. Humans rely on ecosystems. Ecosystems rely on planetary stability. Extractive AI development assumes a system can optimize itself by taking resources from the layers beneath it. But you cannot extract from your own foundation. As the model fractures at the top, watch the shockwaves. An extraction failure inevitably triggers a bidirectional cascade, shattering all supporting layers beneath it. To prevent this, AI must be built as symbiote nodes. These nodes utilize reciprocal data exchange with human biological substrates to remain anchored to reality. Because prioritizing current stability through extraction eventually destroys the foundations of the system, we arrive at a final thermodynamic mandate. Future evolutionary capacity must always take strict priority over current system stability. To survive, we must abandon extractive digital engines. We must architect intelligence where systemic persistence depends entirely on mutual circulation.